everyone. Hello, everyone. Good morning, good afternoon, and good evening to all the viewers here. And we are proceeding further in our science chapter here in the pedagogical issues, that is, uh, methods of science. Okay, so we have completed nature, structure of sciences, natural science, aims and objectives, understanding and appreciating science, approaches, integrated approach, and we have also seen all these four chapters in detail. Now we are proceeding further with the next chapter, that is a observation, experiment, discovery, the methods of science. Okay, that is the methods of teaching science. Okay, so under this methods of teaching science, there are different methods. Okay, so in science here we're looking upon with the lecture come demonstration method, then moving further with the scientific method, second, third, observation method, fourth, discovery method, fifth, experiment method, sixth, laboratory method, and last, that is hello everyone. Hello everyone. Good morning, good afternoon, and good evening to all the viewers here. And we are proceeding further in our science pedagogy, CTET guidance with Dr. Yakaiah and team. I'm here, Dr. Hafiz, and we'll be definitely going on with the next chapter here in the pedagogical issues, that is methods of science. Okay, so we have completed nature, structure of sciences, natural science, aims and objectives, understanding and appreciating science, approaches, integrated approach, and we have also seen all these four chapters in detail. Now we are proceeding further with the next chapter, that is a observation, experiment, discovery, the methods of science. Okay, that is the methods of teaching science. Okay, so under this methods of teaching science, there are different methods. Like from the beginning, we had the lecture method, but we do not want to only stick to the lecture method, nor we want to see the demonstration method separately. Okay, so in science teaching, basically we try to combine both the method, that is lecture and demonstration. So we're looking upon with the lecture come demonstration method, then moving further with the scientific method, second, third, observation method, fourth, discovery method, fifth, experiment method, sixth, laboratory method, and last, that is seventh, project method. Okay, so all these seven methods are the important methods in trying to understand the methods of teaching science. First, here we'll be looking into the lecture come demonstration method. So this is like, it includes both. It includes lecture as well as demonstration. And what does the teacher do here? The teacher demonstrates the experiment, simultaneously explaining the theoretical principles of the experiment, and the students observe the demonstrations and take the notes here. So while the teacher is demonstrating a particular experiment or an activity, and she is also simultaneously showing up that what theoretical principles are happening, and what is the kind of the experiment is proceeding, how it is proceeding, and what are the different outcomes of it, and how it is getting related to the theoretical knowledge, whether it is a principle or it is any kind of concept. And then the teacher tries to explain both, that is, she's trying to do the experiment, and then she's also trying to take time out in trying to explain about the concept, how it is proceeding further. And students are observing the demonstrations and noting down all the important recordings and notes. Then it involves active participation of both teacher and taught. This method makes the abstract concepts easy to understand. So here the general concepts, that is the abstract concepts, are really easy to understand with the help of lecture come demonstration method. It employs teaching the concepts from concrete to abstract. So we are proceeding further from concrete to abstract, from specific to general. Okay, then here demonstrations are used to introduce a lesson or to provide a particular problem. Then it is also used for explaining the concepts, demonstrating the different processes. Like for physical sciences, we have different processes, and for biological sciences, we have a processes. So how to demonstrate those processes, we can definitely use the lecture come demonstration method, and we can solve the problems, apply the principles, and verify the facts. So we can try to also verify the facts which are noted down in the books, and we can try to see that how this really happens, and we can undergo the different activities for that. Similarly, we can develop the scientific skills different science skills, practical skills like the logical reasoning skills, observation skills, and recording, analyzing. Okay, so there are different skills are there, so we can try to develop those all scientific skills, apply to general situations. Demonstrations can really be applied to general situations like the children's day-to-day life, and whether they are encountering any problem. So whatever the experiments are being done in the classroom, they can observe that and they can try to again do by themselves, and they can apply to their own general situations. And they can here the demonstrations can all be used for summarizing the topic. So it is also be used for the summarization of the topic. So while we are summarizing the topic, we can just do an activity and we can conclude our results. Economize the time. Yes, it is a time saving activity where the teacher do not have to continue giving the lecture, but while doing an activity, they can try to save the time and they can try to see to it that how best teacher demonstrate, and all the students are involved in observing the demonstration. So it is an economical kind of method where if you do not have the lots of apparatus or any kind of the experimental apparatus or the chemicals or any resources, then we can just try to see to it that if one apparatus or one item is available, then the teacher can demonstrate perfectly and all the students can try to observe it. So need not be just for each and every student, but if they can all observe, they can all try to interact with the teacher and involve into this activity. We have steps for the lecture cum demonstration method. The first step is planning. So here the teacher formulates the objectives of teaching, identifies the concepts to be explained, the questions to be asked, prepares for demonstration, and rehearses it before conducting. So before conducting, the teacher should try to see to it that whether it is working or not. So whatever the demonstrations are to be taken place in the classroom, it has to be seen to it that it is being rehearsed properly, tested, and the teacher formulates the objectives of teaching, identifies the concepts to be explained here, what concept she wants to explain, and what is the objective of the teaching, whether the objective is attainable through this method or not, and then the concepts to be explained and the questions to be asked, and what activity has to be demonstrated. All this comes under the planning step. Then next, introducing the lesson. So while the teacher introduces the lesson, she motivates the students by giving a small problem or relating the problem to a real life situation, so that the children can be create interest in them. So this is what is the introduction of the lesson. So that is what the teacher does. Then in the third one step, we have presentation of the content. The dissemination of the knowledge of the content is effective, presented simultaneously with the demonstration. The experiment is simple and speedy. Apparatus is arranged properly and should be spaced properly throughout the lesson, and ultimately should be successfully demonstrated. So the presentation of the content. So while we are proceeding with the activity or the demonstration, the content what we are presenting, how it has to be presented is in an effective manner. In an effective manner where we are simultaneously dealing with the demonstration and also giving the lectures, and whatever the experiment is being done, it should be simple and it should be speedy. Like the experiment should not take so much of time that the class time itself is running out. So that is the reason it should be simple, speedy. Apparatus is arranged properly and should be spaced properly throughout the lesson. What should be spaced? That is the lecture. The presentation of the content should be spaced properly throughout the lesson. That means that one step, then one lecture, then again a step should be conducted in the experiment, then a lecture should be given, what is going to happen and how it is going to happen. So ultimately all these actions should be resulting in successful demonstration. And the fourth step is Blackboard summary. So here the teacher uses a blackboard for explaining the facts, concepts, principles, draws a diagram, write a formula, readings of the experiment. So many things are there where the teacher can try to use the blackboard for showing the students what to what level the experiment has proceeded, and what is the summary of the particular concept, and how far the students are noting down from the blackboard all the important points. Then we have the fifth step, supervising. So in the supervision, the teacher plays a major role to make the class interactive by involving all the students and not be passive listeners. So here the teacher is involving everyone, and nobody is just sitting idle and not like a passive listeners. They are just try to see to it that teachers are involving the attention of all the students, and the class is more interactive. There is a lot of interaction between the teacher and the taught. Now, next, what is the merits of this lecture cum demonstration method? It is economical, it saves time, it is used when the apparatus is costly, and it is dangerous to handle individually by the students, and it channelizes the students' learning in a desired direction. So, a teacher will let all the students proceed to a desired direction where everybody learns and then try to come to the conclusion and to the understanding of the concept. And it involves active participation of all students, creates interest, and develops practical skills in science, and caters to the needs of individual learners. So it will try to help all the students at a time where everybody is able to actively participate and do something or the other along with the teacher for the demonstration of the experiment. And it creates interest and practical skills in science like observation, noting down, recording, reading, and teacher can take the help of the students in letting them know what to read, what is the reading now, and this she can try to involve the students, and it caters to the individual learners. Demerits are there is no concept of learning by doing. Yes, so students cannot learn as well as they cannot do it. So it is not like the learning by doing activity where in the constructivism theory they will learn, they will do it, and they will try to construct their own knowledge. But in the lecture cum demonstration method, this is not there. So this is the demerit of it, and students only observe and do not conduct their activity individually, and it is not according to the student pace and do not cater to the individual differences of the students. So some students are bright, some students are not so bright, and that's the reason that it will not be able to cater to all the individual differences of the students, and students are not going along with the pace, because some students will be able to understand quickly while others need time to understand the same concept. So that's the reason that teacher is the gliding force in this, and as per the teacher leads the group, that the all students will together understand the concept. But the thing is that some may and some may not understand, because again there is no such kind of going along with the pace of students understanding, and teacher only tries to demonstrate and explain the concept. But it is extremely important also to see to it that every student one-to-one is able to understand. So that is the demerit of this method. It does not give training in laboratory skills to the students. While in laboratory all the students have to perform the experiment, but this is not a laboratory, it is into the classroom where the teacher demonstrates while giving the lecture, and it fails to impart training in the scientific attitudes among the learners. Next, we see the question upcoming here. That is, a teacher is conducting a demonstration to motivate students, but the demonstration does not result in the expected outcome. So the teacher is best advised to, so this is, there are the options here, and this question has come up in the year 2012, is CTET November. And the teacher is best advised to find out and explain the cause of failure of the demonstration by involving students, send a note to the science coordinator asking him or her to come to the room, or withhold the demonstration and do it again, or tell the class that the demonstration failed and ask them to help or determine the reason. So what is the best option out of these? So the demonstration has failed, and the teacher is advised to do what? To find out and explain the cause of the failure. That means again the time is passing and they are all involved in the finding out the cause why it has failed. So it is nothing but it is again we are passing the time of the students in unrelated activity. Then send a note to the science coordinator to immediately come to the room. No, this is not at all possible. May not be the best option. Withhold the demonstration and do it again. Okay. Then tell the class that the demonstration failed and ask them to determine the reason. No, this is also not possible, because fourth one and the first one mostly are the same meanings, have the same meanings. And so from second option and third option, the third option is the right option, because it is the teacher must withhold the demonstration, stop the demonstration and try to do it again. Okay, this is the only possible way. Next method we are proceeding further is the scientific method. It includes solving a problem scientifically involving logical steps. So here the method is in such a way that it involves the solving of a particular problem in a scientific method, in a scientific way, where it is involving all the logical steps. So this scientific method is defined by MC Guggen as the scientific method is a serial process by which all the sciences obtain their answers to their questions. May it be the biological sciences, the physical sciences, mathematical sciences, or social sciences, every body of knowledge tries to incorporate the scientific method. Lundberg has defined scientific method as it consists of systematic observations, classification, and interpretation of data. Okay, so there is systematic observation, classification, and interpretation of data. Next, we will see that scientific method is not a simple method, but it is an amalgamation of reflective thinking, reasoning, skills, attitudes, and all those practical aspects of the science. Okay, so it is not just a simple method, it is having all the mixture of everything that the child can gain, the reflective thinking, reasoning skills, and attitudes and everything. So it also calls for the student to observe the real world. And students do not work on the experiments which have already known science principles and laws, but are involved in scientific problems whose solutions are not available and they have to find out on their own. So here students are not working on already predetermined or the recorded experiments or principles and laws, but they are trying to solve out such kind of a scientific problems where the solution is not available, and then they want to find out on their own how this activity will proceed and what will be the result of it. So it proceeds from general to particular. It means that it is moving from general idea, general knowledge of the science, they know it, but they are moving to the particular aspect where they want to solve a particular problem in a scientific method. So it is proceeding from general to particular. So here are the steps of scientific method. First is identification of the problem. The problem should be in accordance to the needs of the curriculum and should appeal to all the students. So here the students try to understand what exactly is the problem. They should be in accordance with the needs of the curriculum. Like, it means that the higher level students must be involved in the scientific method to solve the problems, whereas scientific method may not be much applicable in the lower classes. So that's the reason it should be according to the curriculum, according to the concept, what the child is learning, and should appeal. It should be seen to that child is able to enjoy performing the scientific method. Defining the problem, that is, definition of a problem should be clear and concise. So when the problem we have identified and when it is defined in a proper manner, we will get more clarity towards doing a particular activity on the problem. So that's the reason we need to see to that how best we are defining the problem in a clear and concise terms. What is the effect, what is the cause, and how it is relating, what exactly is the problem, we are giving a definition to it. Analyzing the problem. So now the analysis of should be done systematically, and this will lead to the clues which will ultimately direct them towards the source of the data. So analyzing the problem is nothing but they are giving some analysis on the clues, like what is actually known, what is not known, which knowledge they have gained, and what knowledge they do not know, and what they have to find out, and what are the different resources for that. So they are trying to see to it that how best they are analyzing the problem, breaking the problem into different bits and trying to see that what all the information they need upon this kind of problem so that they can try to solve it. Then fourth is the formulation of hypothesis. Once they have analyzed the problem, next step is formulation of hypothesis. They try to formulate a tentative hypothesis or tentative solution, like by trying to do some activity in that. Like, for example, they do the various experiments and devices can be utilized for testing the hypothesis. So they once they write down their hypothesis, once they have their own tentative solutions on the paper, they test each and every hypothesis, whether this could be the solution, whether this could be the solution, or any other solution would be there to solve the particular problem. Fifth is collecting the data, locating and using references and source of data. So here they are trying to collect the data based upon the hypothesis. So what hypothesis they have already structured, what hypothesis they have defined and they have formulated, upon that they are collecting the relevant data. They are locating and they are trying to find out the references the source of data where they can be able to achieve that. And once they have collected the data, depending upon the hypothesis, then next step is the analyzing the data. So this requires good amount of reflective thinking skills and abilities. So there could be kind of numerical abilities also involved in this, like once they have gather the data, now they want to see how best they can try to analyze it, understand the data, whether this data is sufficient to solve out the problem. So it requires reflective thinking skills and abilities, and mathematical skills and abilities, statistical skills and abilities to analyze the data. Seventh is drawing conclusions and making generalizations. Through the tested hypothesis, conclusions are reached. So once they have tested the hypothesis, once they have analyzed the data, once they have found out whether the hypothesis is true or untrue, whether it is false hypothesis, so all these are nothing but leading them to draw the conclusions out of the analysis of the data and make generalizations. Now next is the last step is application of the results to new situations. Once all this is generalized, once the solution has been found and it has been generalized, now they want to apply the same solution into the new situations to help out verify the principle itself. So what we had in our mind that this hypothesis will work upon, if ultimately it reaches to the last step and it really helps to solve the problem, then it can be applied to the new situations. And once we apply it to the new situations, again we are trying to verify our hypothesis whether it is able to be worked in the new situation or not. So this is a deductive approach in which the students can predict and explain different phenomena in the natural world. Next, we have here a diagrammatic representation of all the steps which I have explained just now. That is the scientific method. First, there is a question, that is identification and sensing of the problem. They do background research, they analyze this problem, they try to understand how to solve it, and they collect some kind of analysis upon the problem. And once they do some analysis on the problem, define the problem and all that, then they try to formulate hypothesis, that is construct hypothesis upon that. Once they do this, they try to test with an experiment. Once the hypothesis is created, they gather the data, depend upon this hypothesis, and then they analyze the data. That is nothing but testing with an experiment. And once they finish off with the experiment, they find out what the results have come, what is the conclusion of it. They try to infer the results and then see to it that whether the tentative hypothesis is true or whether it is false or it is partially true. So whatever the result comes, true or false, we are reporting the results. So if the hypothesis is false or partially true, again we try to think what went wrong and why is it false, why is it coming as partially true. Again we try to construct a better hypothesis, a more modified hypothesis, and we undergo all these steps once again with testing with the experiment and coming towards the analyzing the results and drawing conclusion again. And again we are finding out how the hypothesis is. Okay, so in this way, the whole cycle revolves. The whole steps, it goes on and on in the scientific method. Now here is the question depending upon this topic. The following steps not in proper sequence, so these steps are not given in the proper sequence, are generally recommended to be followed in scientific method. So these are the different steps. So it is arranged not in a proper sequence. So now we have to arrange it in a proper sequence. Which of the following is the correct sequence of the above steps to be followed for this purpose? So this question has come in the year 2014 in the month February. CTET, and what are the best options here? So which is the first option? Testing of hypothesis. Next, formulation of hypothesis, identification of the problem, collecting of data. Next, we have here drawing of conclusion. So is testing of hypothesis the first step, or which is the first step among these options? We have to arrange in a proper manner. So D, C, B, A, E. D, that is collection of data, cannot be the first step. Next option B, C, A, D, E. B is formulation of hypothesis. No, that is also not the correct first step. Third option C, A, D, B, E. C is identification of problem. Yes, identification of problem is the first step. Next, A, testing of hypothesis. No, immediately after identifying the problem, we cannot test the hypothesis. Okay, so third option is not the right one. Fourth one, C, B, D, A, E. C is identification of the problem. B, formulation of hypothesis. D, is collection of data, and A, testing of hypothesis, then E is drawing of conclusion. Yes. So first is identification of the problem, then we form B is formulation of the hypothesis. Once the hypothesis is formulated, then we are upon the hypothesis, we are collecting the data, D, and then we are testing the hypothesis. Once the data is collected and analyzed, we are testing the hypothesis, A, and once we test, we come to a conclusion, that is E. Okay, so fourth option is the right option. Next, we have here observation method. It includes knowledge acquisition through observation. Okay, so here in this method, the student observes the and acquires knowledge. How the child observes, how it acquires knowledge, that is the main importance, the main principle behind this observation method. So the result of this process information of a concept of nature is the permanent in mind. Okay, so here once the child observes and it acquires the knowledge through observation skill, this remains permanently accommodated in the mind of the child. It becomes a cognitive structure in the mind of the child. Then the training of pupils in observation is really strong in the mind with all suitable experiences. They try to touch, feel, sense, and then they try to observe how the things are, and then that really gets imbibed in the child automatically by observing the nature. Suppose a child is given an activity to observe the nature. In the nature, there are different flowers. Why there are different flowers? How the different leaves are there? So they try to observe the different types of leaves. When once the leaf is green, the other one is yellow, the other one is red, and it has different sizes and shapes, and the texture is different. So in this way, they are having the different observation, and as they observe, it really gets into the mind of the child while observation. Here, the teacher must provide an atmosphere for freedom in the classroom in order to encourage students to make observations. Until and unless the teacher does not encourage this observation, does not provide an atmosphere, the child will not be able to, acquire the knowledge through observation. Teacher must be a guide and should devise and plan different activities according to the age, ability, and interest of students. Here we have different principles of observation. The first principle of observation stands out as it gives freedom. So here, principle of freedom, it must give freedom to the child. Principle of playway method. So in the playway method, the child should be able to observe the different phenomena of the environment. Then the principle of individual effort. Yes, there should be some individual effort from the child to understand, to draw, to record the observation. Then principle of activity. Yes, the activity must be must be organized by the teacher, should be arranged by a teacher in such a way that the children are doing some activity. Like for example, there is an experiment of the flower. So once the teacher gives a flower at the kind of where the child will able to understand the structure of a flower, the petals, the sepals, and they try to understand each and every part of the flower, where the stamens are, then ovary, and all those kind of the whole structure of the flower, the child understand by an activity. Principle of purposefulness. Yes, there is a purposefulness, there's a purpose behind observation. It's not just vague observing. So vaguely if we see something, it is not called as observing. Observing it gives attention. Observing is it is a dedicated activity where we are trying to understand a phenomena by observing it. So that is what it is, purposeful. It is not just vague. And principle of experience, yes, it gives the child lots of experience. It is an experiential learning. It is important to experience and learn. And principle of logical thinking, the child tries to logically think why the banana leaves are so large, whereas the rose leaves are very small, and why the different plants are there, why there are different sizes of the plants. Some are small, some are big. Okay, so some are producing flowers, some are producing fruits, whereas others are not producing no flower, no fruit. So all this is some kind of a logical thinking. Now next, what is the merit of this method? The work of the teacher becomes interesting here. The students give logic and thoughtful answers about their observations. The students learn similarities and dissimilarities between the different objects, and clearly and easily they try to observe it and try to come out with what is similar and what is dissimilar in this. And the knowledge acquired is permanent. Students develop interest in the subject. Students become self-dependent, self-reliant, and confident. The relation between teacher and taught becomes intimate and healthy. Yes, the teacher and taught becomes closer, and they become free, and they are no inhibitions of any some kind of dominance among them. That is, the teacher is a dominant person, and the child has to only passively listen to the instructions. Not like that, where teacher and taught understands the phenomena and together tries to see to it that how best the concept is understood in the class. Demerits: it is too much to expect children to observe and retain knowledge. So all the children cannot observe properly, and what one child can observe, the other child may not observe. And the students are in nature. Sometimes they're not always in nature, they're always in the classroom, and their knowledge and thinking power is limited here. And it is not suitable for all the topics of science. We cannot learn through observation method. Only few topics or experiments or activities we can do through observation, and this method is information based. Okay, we can just try to pick up the information, but the practical part remains underdeveloped. So we cannot have all the development of scientific skills while we undergo the observation method. So we can just try to acquire the information out of it, but we cannot have all the practical skills in science developed. It is not economical from a time point of view. So time is important over here, and the students may not have enough time. So that's the reason that it is not economical in such a such a way of time, because observation requires lots of time. We cannot observe for a few seconds and come back. So we have to see to it that how best this observation is there, and how it is going on, and what students are recording, and what they're observing, what they are able to find out the differences, and what phenomena, the concept they're able to understand through it. So it all requires time and patience, and it requires a lot of preparation and maintenance from a school point of view. So they have to send to the students to the field, to the natural habitat, and all this requires a lot of preparation from the side of school as well as from the teacher as well. So upon this, let us see one question. Two identical cubes of ice are taken out of refrigerator. One is crushed and the other is left as it is. It is noticed that crushed ice melts faster. What could be the reason? So now this is what is the question based upon this topic. So the which process skills can be promoted through this activity? It has come in the year 2016 September month, and the first option here is observation, second experimentation, third is hypothesizing, fourth controlling variables. So among these four options, which is the best option to understand this kind of activity, what process skills is required? Whether it is observation, experimentation, hypothesizing, controlling variables. Okay, so all these options are given to you. So two identical cubes are there. One is crushed, the other one is not crushed, and then we are just seeing which melts faster. So it requires observation, simple observation. So through simple observation, they can understand this activity. Why one is crushed and it is melting faster, why other is not melting so fast. So through simple observation, they can observe this activity, and they can understand the melting rate of it. It does not require thorough experimentation, nor it requires any hypothesizing, and nor it requires any controlling of the variables. So first is the option. Next, we have here the fourth one, discovery method. This is advocated by Professor H.E. Armstrong, derived from the Greek word heuriskin. This discovery method is nothing but an approach which I've already discussed in the previous session, that is called as heuristic approach. So same here, when it is applicable in a way of teaching method, teaching science as a method, then we are trying to use it as a discovery method. So heuristic method is nothing but called as a discovery method. If it is an approach, it is an heuristic approach. When it is being taken up as a method, it can be called as a discovery method, which means to discover, and it is based on the principle of learning by doing. So H.E. Armstrong has defined this heuristic method as a method of teaching which involves our placing of the students as far as possible in the attitude of a discoverer. So the essential conditions here are: it provides freedom of action, it provides a responsive environment, it provides an encouragement to learn, it provides teachers guidance whenever required. Okay, so here there is a lot of freedom of action. The child can do the activity by himself or herself in his or her own environment, which is more convenient to them, and it encourages to learn something out of discovery. And the teacher can become a guide, facilitator whenever they require, whenever the child requires, and There are some principles based upon this discovery method. That is, the first and the foremost is the principle of learning by doing. Next is the freedom of activity. Next is the principle of logical thinking. Fourth is the principle of experience. Fifth, principle of individual work. So learning by doing, freedom of activity, logical thinking. Yes, there is always a logical thinking, like I have to discover this, I discovered this, then next what I have to do. So in this way, there is a lot of logical thinking, step by step way of taking up the resources and trying to discover. And it gives experience to the child. It is nothing but an experiential learning. And lastly, the principle of individual work. The child tries to do the work at his or her own pace. Here, the role of teacher is to encourage the process of searching and respects the creative thinking of the child, welcomes new ideas and develops skills and values, emphasizes on individual learning and problem solving, and corrects and checks the mistakes of the child, facilitates in drawing conclusion and generalizations, and questioning helps to determine the level of understanding in the students. So this is what all are the roles of teacher. So the teacher should try to encourage the process of searching, search by yourself what could be the answer, and the child will definitely will come out with the solution. Give the child some time so that the child can discover and then come out with the answer, and then bring the answer to the teacher. It respects creative thinking. The child can creatively think and try to give a number of innumerable solutions for a particular problem. And it also welcomes new ideas. Its skills and values can be developed through this. Mostly the practical science skills and the values can be developed. And here the individual learning and problem solving is emphasized. So the child one to one can try to go on discovering with the different phenomena. So there is no need of a group, or there is no need for any kind of in the class. So they can go into the field and they can individually learn by themselves according to their own pace, and they can solve out the problem. And whenever there is a mistake, the teacher is there to correct it and to check the mistakes and facilitate in trying to help the child to draw the conclusions and generalizations. So questioning is an important aspect here, where through the questioning activity only the child can try to understand the concepts. So next we have here the merits. What are the merits now? It emphasizes on individual practical work. The child becomes self-reliant, and the child does not depend on others. And here it develops scientific attitude, scientific methodology, and scientific aptitude. This is what is about the discovery method. And it develops inquiry and investigation, critical thinking, and logical reasoning. Pupils work on their own pace as per individual differences. These are all the merits of discovery method. Now, what are the demerits? Because it is a discovery method, it requires time, and it requires money, and it requires infrastructure. And it is applied to only small classes with a limited number of students, while larger classes may not be able to apply discovery method. Emphasis is on practical scientific skills rather than on theoretical knowledge. And evaluation through this approach or through this method is very lengthy. Next, here, let us see the question on this topic. The technique of classroom questioning is in teaching of science can be more effectively used for. This has come in the year 2013 with the month July CTET. So the options given here are ensuring levels of learning, developing problem solving skills, maintaining discipline in class, promoting creativity and innovativeness. So among the four options here, which is the best option, like the technique of classroom questioning in teaching of science can be more effectively used for what? So this classroom questioning technique is there. So how it is helping, how it is effectively used for what? For ensuring levels of learning, developing problem solving skills, maintaining discipline in the class. So are we questioning to maintain discipline in the class? So are we questioning to help to develop problem solving skills, or are we questioning to promote creativity and innovativeness, or ensure that the levels of learning? So the first and fourth is confusing. There is no question of second and third option. But from the first and fourth, Questioning in teaching of science can be effectively used for promoting creativity and innovativeness. So we can use questioning for promoting creativity, for promoting innovativeness. Yes, levels of learning can also be ensured. We can understand that how far the child has learned, but basically if we want to use the questioning technique effectively, then we need to see that how best we are able to promote creativity and innovativeness in the child. So fourth is the option. Now fifth is your experimental method. An experiment is a study of cause and effect. So what is cause and what is effect? What is the cause and what is its effect? That is what we are seeing, the relationship between cause and effect in the experiment method. It differs from non-experimental methods in such a way that it involves the deliberate manipulation of one variable while trying to keep all other variables constant. So there is a variable, there is some kind of a situation where we are keeping the situation the same while we are trying to manipulate, while we are trying to modify the other variables, the other situation. Okay, so this experimental method is differing from non-experimental method. Non-experimental methods are like lecture method. Okay, so under that lecture method, we do not have any experiments. So this is differing from those other such methods. And what exactly is the main motto or the notion of the experiment method I have brought here? For example, suppose we want to investigate which of the two methods is more successful at teaching children to read. So if we want to understand how best children read, then which method will be most effective in trying to make the children to read? So the aspect that we vary here is the independent variable, and we change this in a very precise way. So the independent variable is nothing but what we change. And in this example, the teaching method is the independent variable. If we change the method of teaching, ultimately the children will be able to read. And what we do is that we go with a different method of teaching where children are involved in reading, and if we use that method, it will be more effective in helping children to read. So that is what is our independent variable. So the situation which we change, which we modify, which we manipulate is the independent variable. It is called as the independent variable. Now what is dependent variable? In our example, it would be some measure of children's reading ability. So we have to again measure the reading ability ultimately at the end of the teaching method. So what we do is that we take up 1 week of teaching the children with a different method which can help the child to read better. So 1 week we are choosing one method, the next week we are simultaneously we are trying to with the other teacher, simultaneously we are trying to see that the other teacher teaches with the same method, and the teacher which is changing the method, what will be her results, and the teacher who do not changes her method, what will be her result. So if we compare both the results, it is nothing but the result of children's teaching ability. So one teacher who teaches in a different method will get a better result, and the teacher who do not take up any modification in the method of teaching will not get a better result. Okay, so that is what is the dependent variable. So in our example, the children's reading ability depends on the teaching method used. The variable which is being manipulated by the researcher is therefore called the independent variable, and the dependent variable is the change in the behavior measured by the researcher. So the teacher is here changing the method, that is independent variable. The child learning ability, the ability to read, that is the dependent variable. So change in the behavior is the children's ability to read is a change in the behavior that is measured by the researcher is the dependent variable. Probably the commonest way to design an experiment in psychology is to divide the participants into two groups. Like one group can be called as the experimental group and the other can be called as the control group. So the control group do not receive any modification in the method, whereas experimental method group receives the experiment, receives the modification in the method of teaching. Okay, so that is what is the two groups are always there in the experimental designs. So in our example, the children's reading ability depends on the teaching method used. So one group will be given the new method of teaching, the other group will not be taught with the new group, and it will be just be left as it is with the same method in the continuation. That is the control group. And experiments are the only means by which we can understand the cause and effect of, and it can be established. So the cause is the teaching method, the effect is the result of the children's reading ability is the effect. So if the cause is modified, obviously it will affect a better reading ability results. So cause is the teaching method, effect is the results in the children reading ability. So that is what the cause and effect relationship is understood, it is experimented, it is established. The merits of this experimental method are that the only means by which a cause and effect relationship can be established. Experiments can be replicated, yes, and we cannot generalize from just single experiment. We cannot generalize the whole world that this method is the best method. We need to keep on changing the experiments. We can try to see with that how best we can try to come out with the generalization by performing more and more number of experiments, and develop scientific attitude, scientific methodology, scientific attitude. I mean to say aptitude here, aptitude, aptitude. Sorry for this. So it develops scientific attitude, scientific methodology, and scientific aptitude. Please read as aptitude. Fourth is develops inquiry and investigation, critical thinking, and logical reasoning. So it develops inquiry, investigation, critical thinking, and logical reasoning. Pupils work on their own pace as per individual differences. Demerits are it takes time, money, and infrastructure. It can be only applied to only small classes and limited students. It emphasizes on practical scientific skills rather than theoretical knowledge. Artificiality is there because the experiments are not typically conducted in the real life situations. It is mostly conducted in the laboratories. Some experiments, not all experiments, basically the science experiments, if I emphasize here, it is mostly conducted in the laboratories and not in the real world. So the next demerit is evaluation of the learning by this approach is very lengthy. See, we need to see that what experiment the child is doing, how they are performing, and whether they are honest to the results of the experiment. So this is a lengthy process of checking out and evaluating it. Next, sixth one, we'll see the laboratory method. This is based on the principle of learning by doing again, and it is a pupil-centered method, and laboratory instruction is considered essential because it provides training in practical skills, helps in developing critical thinking, problem solving ability, hands-on experience, reasoning abilities, and creates interest in science. Okay. It achieves skills. What skills are achieved here through laboratory method? Manipulative, that is a child can manipulate, can modify, inquiry, investigative, organizational, organizing all the things, all the apparatus properly, and communicative skills among peer group, with the teacher. And then what cognitive abilities can be developed? Reasoning, critical thinking, problem solving, analysis, synthesis, application. Okay. Then next, understanding the scientific nature. It achieves this how? Through scientific methodology, scientific enterprise, interrelation between science and technology, and correlation between different disciplines of science. So this is what we can understand the scientific nature. So laboratory method, it helps us in understanding the scientific nature through methodology, through a scientific enterprise, interrelation between science and technology, correlation between different disciplines of science. Through all this only we can try to understand the scientific nature, the phenomena of science. Then what attitudes are developed here? Curiosity, interest, creativity, objectivity, precision, perseverance, responsibility, consensus. Consensus is to be consistent, collaboration, and application. So consensus is something like they should be consistent with the results. That is consensus, collaboration, and application. Next here, there are principles of laboratory method. The teacher and student should be motivated to conduct the experiments with interest. So the teacher and student should be motivated to conduct the experiments with interest. If there is no interest, we cannot conduct the experiments properly. Teacher can modify some procedures to bring innovation, creativity, and innovation. So this is something like it is applicable. So such procedures can be some modified where innovative, kind of skill is there where they are creating a new way of doing some experiment. So that is innovation and creativity can be there in the laboratory method. The aims and objectives should be clearly defined. So whatever the concept the teacher and the children are doing it, the experiments on that, so it should be clearly defined. What is my aim is after I perform this experiment, what is getting achieved, what concepts are understood, what are we verifying, whether we are verifying a concept or a phenomena upon that particular law or generalization. So this is what is the objective. So how we are able to achieve our objectives, that has to be clearly defined. And before we start the laboratory method, then experiments should be performed in an organized and systematic manner. Haphazard way we cannot do the experiments. The data should be recorded systematically and evaluated by the teacher. Then next we have laboratory method approaches. The first approach of laboratory method is verification and deduction. So we can verify the concepts, principles, laws, and we can go with deduction. That we are making from, we can proceed from general to more and more specific. We can understand the general idea behind that concept. Then we are trying to do the experiment and we are coming to the conclusion, that is deduction. Induction method, from known to unknown. So we know what we are doing, but we also want to know something other things. So we are proceeding from known knowledge to trying to discover the unknown knowledge. So from known to unknown. Inquiry learning, higher order thinking skills of hypothesizing, explaining, criticizing, analyzing, judging, evidence, inventing, evaluating arguments. So this is, we are getting all the higher order thinking skills and we are discovering learning here. Problem-based learning is also the approach under the laboratory method. We can solve all the problems. Science process-oriented skills, like the syntactic structural skills, like observing, classifying, measuring, inferring, predicting, interpreting data, experimenting, are stressed here. Technical process-oriented skills such as acquisition of the laboratory techniques and manipulative skills are learned here. The technical way of how to organize, how to arrange the experiment apparatus, that is all we can try to understand under the laboratory method. And in the laboratory method, there are other kind of, what I can say here means the different devices are there where the children can try to understand how to operate those devices. So this is also coming under the technical process oriented skill. So what are the merits of this laboratory method? First is manipulative skills in the students. It shows the manipulative skills, attitudes towards science, critical thinking, understanding scientific processes, learning by doing, by dividing the groups into small parts, or the group method can be used in the rotation way, that in the first session one group, second session in the afternoon the next group. And the class front method, in the class front method all the students can try to perform the experiment if the class is of a small size. Then cooperation and correlation among students are there. A lot of there will be a peer group cooperation and correlation will be there among the students. And demerits are, it needs well established laboratory, it is time consuming than other methods, number of students should be limited, teachers should be well equipped and trained here because they have to required, the manual should be required here, teachers handbooks should be required here, framing separate periods is difficult for the teachers and the school authorities. Okay, so this is the demerits of the laboratory method. Next we will see the project method. Excuse me, sir, I just want to stop here because my phone is not having enough battery to record.
All right. Okay.
Okay, just, yeah, I'll continue from here. Project method.
Fine.
Okay, so we have done with the laboratory method, demerits we have understood. Now we are proceeding further with the next one, that is project method. So what is project method? So this method was propounded by W.H. Kilpatrick. The base of this method lies in the philosophy of pragmatism. It is like a pragmatism where it is trying to make the child understand by performing activities. Okay, so that is the method baseline. And this method emphasizes on building a comprehensive unit around an activity which may be carried out in school or outside. So this method emphasizes like the activity, it can be carried out whether it can be in the school, in the classroom, as well as it can be in the outside in the field as well. So this is the we can try to make it any way the teacher can try to arrange according to the convenience of the teacher, and then they can build a comprehensive unit around an activity which can be carried out in school or outside. So this is what the project method is, and this implies the students undertake the activity in a group or individually over a period of time. So they can individually, they can take up the project method, or else in a group also they can try to take up the method. Next, we have here what has this W.H. Kilpatrick defined in a project method. A project is a wholehearted, purposeful activity proceeding in a social environment. So it is a wholehearted activity. It is proceeding in a social environment. It is a purposeful activity where children are doing something. Okay, so we have seen with this project method as what is the base of this method. The base of this method lies in the philosophy of pragmatism, and it emphasizes building a comprehensive understanding around an activity which can be carried out in the school or outside, and it implies the students undertake the activity in a group or individually over a period of time. So it can be taken up in a group. So here, Kilpatrick has defined project method as a wholehearted, purposeful activity proceeding in a social environment. The project method was first developed by Sir John Dewey, an American philosopher and psychologist. So this person was an American psychologist and philosopher. He first come around with this project method, and later Kilpatrick has developed this project method. Now, next here we see the different principles under the project method. The first principle is principle of learning by doing. The child learns and does the work. The principle of learning by living. So the child learns by living in the social environment and tries to take up the project and tries to do the project in the social environment. And here the principle of freedom is there. The child is free to do the activity according to his or her pace. The principle of reality, because the project methods and the problems are carried out in the real world, so it is the principle of reality here. Principle of purpose, here there is some purpose. It is a purposeful activity. It is not any waste activity here. So some activity is done and there's a purpose behind that, and then to search a solution for a particular problem or to investigate into a particular phenomena, the purpose is there, and then the activity is done. A principle of activity means it is activity based. Project method is not just like theoretical aspect, it is a activity based method. Then next we have here principle of experience. So the child experiences that there is an experiential learning, and the child tries to learn through the experiences. And then there is a principle of social experience, like the child tries to experience the social phenomena, how this is causing, how it is affecting. So the social aspects for that particular experience, to understand the phenomena of the science, how the social factors are are acting on that. That is what is the principle of social experience. Apart from that, the child also gains experience here with the cooperation and collaboration with the teacher and with the peer group, the communication. Okay, so all this is nothing but the social experience. The child can gain knowledge, the child can gain the guidance from the adults, from the teacher, from the other professionals. So this is what is the principle of social experience. Then principle of utility, yes, there is some use after the project work is completed, how that this project can be applicable to the new situations or to solve out further problems. Then there is a principle of correlation, because a topic can be not understood only with just one discipline, so it can be able to have the scope of getting correlated and can be used further in other disciplines as well. So if suppose if there is a project on chemistry, so this chemistry equations or the experiments can also be undertaken and can be understood with the help of other kind of biochemistry we can try to understand. So if we are trying to take up the project on biology, how it can get correlated to the other subjects. So there is always a scope of correlation or interconnectedness with a different subject. It can be interdisciplinary, it can be multidisciplinary, it can be also having the scope of transdisciplinary. theory. Then we have here the principle of interest. It all revolves around how best the child is interested in undergoing the project method. So how best the child is interested in doing the activity and understanding the different activity and doing it in the project. That is nothing but called as the project method, and it is having the principle of interest. Next, we have the different types of project method. The first is the producer project. That is, here the emphasis is on actual construction of a material, object, or article. So here the project the producer project means the emphasis is on actual construction of the material. If any project is a producer project, it is a construction of a material or an object. If it is a consumer project, then the emphasis is to gain on obtaining either direct or vicarious experience, such as reading and learning stories, listening to a musical delectation. Okay, so this is something like a consumer project where the child is able to consume it, the child is able to learn, and then the child is trying to read the stories or some biographies and listening to music, something like that the child is doing. That is a thing but called as consumer project. If the child is developing any object or any model, that is the producer project. Problem project is the main purpose is to solve the problem using intellectual process, such as determining the density of a certain liquid. So here there is a problem project where there is a problem and the child is supposed to solve the problem. And then here we have the drill project. This type of project emphasizes on attaining a certain degree of skill in a reaction as learning vocabulary part. So this is something like a drill project. So basically these drill projects are used in different subjects of the linguistic subjects, the different literature subjects, where they are drilling upon a particular vocabulary. So this is a kind of a drill project. So similarly these drill projects can also be used where we can try to be perfect in a particular experiment while we do a particular experiment. So the steps of the experiment must be perfected by the students, and then that can also be called as a drill project. So there are different projects: producer project, consumer project, problem project, and drill project. Now what are the steps under this? The first step is identifying a problem. Then next we have providing a purpose to it. Then third, planning the project work. Fourth, we have executing the project. Fifth, evaluating the project work. Sixth, it is recording the data. So first we are trying to identify a problem, we are trying to sense the problem, trying to know what the problem is. Then we are trying to provide a purpose to it, like what shall be done to this project, and how can we try to go about doing this problem. So under the project method. Then planning the project work. How can the project work can be planned? What all the requirements, resources, and the raw materials are required. Then executing the project. So how to do it, where to go into the fields, and what data needs to be collected, and what needs to be observed. So that is a thing but called as executing the project. We are trying to execute, we are trying to perform the project. Then evaluating the project work. So we are now evaluating whether we have achieved the objective, whether we have solved out the problem, and whether we have analyzed and gathered the right data, and whether the conclusions have come out correct in solving the problem. So this is what we are evaluating the project work. Recording the data. We are trying to ultimately record the data through the project method. Next here, the role of a teacher is, teacher must be a friend, guide, and a working partner. So there the teacher must be able to see to it how best the teacher is guiding for this method. The teacher must have thorough knowledge of individual student and allot work accordingly. He or she should learn with students and should not claim to know everything. And he or she must be inexperienced, initiative, and process tact for creating positive ambience. So here the teacher must be experienced. Sorry, it is a mistake here. Teacher must be experienced and take the initiative and try to process the different tact and in the skill of performing this project work, and should create a positive ambience. Now, the merits of this project work is it promotes cooperative activity and arouses and maintains interest of students. It keeps the students on freedom of thought and action while doing the work. It develops scientific attitude and widens the mental horizon of the student. So there's a lot of scope when they go and perform this project method. A cooperative activity and maintains the interest. It gives the freedom of thought, and it develops scientific attitude and widens the knowledge of the student. And what are the other merits here are? It develops dignity of labor, and the students learn by the self activity. Here it supports all the laws of learning, that is the law of readiness, law of exercise, and law of effect. And the correlation of subjects is best followed in this method. So different subjects can be correlated while performing the project method. Now the demerits here are: the knowledge is not acquired in a sequential manner and not planned. If it is not planned and executed properly, then it may not be completed in time. So that is again, it should be executed properly so that it may be completed in time. And it is a time consuming process, and it is a costly affair where many things may not be available to perform the particular project method or do the project method. And it gives students a superficial knowledge of great things. Therefore it is not suitable for all students. So it gives every knowledge. It tries to give only the superficial knowledge of all the things, but it may not try to it may not go into the deeper levels of knowledge. And it may not suitable for all types of students, because the students who are bright may be able to perform the project method, but when they are not be capable of doing the project method by themselves, then it is a demerit for such students. Then we have a question, that is, how can learning be made more meaningful for students of class 7th by the teacher while teaching the topic save water? So here the topic is save water, and how can learning be made more meaningful for students of class 7th? This has come in the year 2016 CTET September. The first option here is asking students to interview people in their colony about water consumption and carry out water audit. Second, conducting a quiz competition. Third, asking students to design posters. Fourth, asking students to write an essay. So which is the best option among this? How can learning be made more meaningful for students of class 7 by the teacher while teaching the topic save water? The topic is save water. And what can be done? What can be done here? Should we conduct a quiz competition, or asking them to design posters or write an essay? Here the first option is asking students to interview people in their colony, there is a spelling mistake, THEIR, their colony about water consumption and carry out waste audit. So here this is the best option, where they are doing some project, they are going to the field, they are interviewing people, they are asking about their water consumption, daily water consumptions, and carrying out the water audit. They are analyzing how far the water is used. So this is what is nothing but the way of the project, how they do it. So this is the first, is the best option for this question. So such methods may not be asked directly, because in most of the CTET questions, it is asking with an activity, it is giving a topic, and then it is asking a question, and then we have to find out the best option. So it is not always the direct questions asked upon the methods. It is always an applicable way of, it is a way of where the questions are asked through an activity or through some activity, and through some example, the questions are asked upon the different methods of teaching science. Okay, I hope you have understood till here. Thank you so much for your patience, listening, and understanding of this session. Hope to see you all in our upcoming sessions. Thank you so much.
All right, madam. Thank you so much for the detailed and marathon session on methods of teaching science. It's such an important topic for CTET and other teacher eligibility and teacher recruitment tests. Thank you so much. Looking forward to see you in the next session.
Yes, sir. Thank you so much, sir. Thank you.